Hello, this is the first in a series of videos on trigonometry, and in this video we're going to briefly discuss some basic facts about angles. So we'll start by drawing a simple picture. I'm going to put a little dot here, and we're going to label this point A. Then I'm going to draw a line like this. This is called the initial side. And then draw another line like this. This is called the terminal side. A has a name. It's called the vertex. And let's draw our angle here in red. This is our angle, which we'll call theta. So theta here is our angle. So when you think of an angle, you want to think of basically a measurement, and we're going to be using, for the most part, degrees for now to measure angles. And it has an initial side and a terminal side. So the angle starts here and it ends here. And so this measurement is the measurement called an angle. And theta here is going to be in degrees. A simple way to think about this is if you make a complete revolution, you're going 360 degrees. So for example, if I were to start here and go all the way around, this would be a 360 degree angle. Likewise, if maybe instead I only go halfway, so I start here and I end up here, this would be 180 degrees. And why not, just if you're curious, if I start here and I end here, this would be a 90 degree angle. It's a really intuitive way to measure angles. Let's talk a little bit about some of the important angles. I'm going to switch color here. So an angle like the one we have up here, I'll draw it again down here. So something like this is called an acute angle. So this is acute. And in this case, our theta is between 0 and 90 degrees. So acute angles are the smaller angles. Let me go ahead and fix that. There we go. That's the degree symbol, by the way, this little O here. So this is read 180 degrees, 90 degrees, 360 degrees. It's a really important habit to get into, that whenever you're discussing an angle, always put the little degree symbol. If we have an angle that looks like this, well, based on our previous pictures, this one is a 90 degree angle. This one is special. So when theta is equal to 90 degrees, this one's called a right angle. You might have heard of right triangles. Those are studied a lot in trigonometry, and those are triangles that have a right angle. And we have some more fun ones. This is my favorite one. It's got a funny name. So here's the terminal side. Here's the initial side. This is called the vertex, just a quick refresher. And then here's our angle theta. So in this case, theta is between 180 degrees and 90 degrees. In this case, theta has a special name. It's called an obtuse. Angle. Funny name, right? Obtuse angle. And the very last one is not so interesting, but it's still important to know. So you have an angle that starts here, goes all the way around and ends here. So this one is a 180 degree angle. Theta is 180 degrees. This one's actually called a straight angle. Some general conventions that are important should be noted. So you'll notice that every single angle I drew has two special properties. One, they've all been drawn counterclockwise, right? So it's the opposite of a clock. So this way, this way, this way. And two, they're all positive. So the default in trigonometry and in mathematics in general is that positive angles are counterclockwise. So counterclockwise indicates that we have a positive angle, so it's positive. That is the convention that is used throughout mathematics. And then clockwise, well, it's the opposite of positive, so this would be negative. So a negative angle goes in a clockwise direction. As a concrete example, let me just give you a simple one. Let's say here is our vertex. Remember, it's called the vertex. This is the initial side. And let's say it goes down like this. And then this one here, if you remember, this is the terminal side. So this is the initial. This one is the terminal. Just good extra life knowledge. And this point here was called the vertex. Again, it's good to, when you're working through these videos and when you're reading, when you're working through the videos and reading the words, it's good to like verbalize what's going on. This is a negative angle. Maybe this is negative 60 degrees. So theta here is negative 60. This would be a negative angle. So there are some important things or some useful things that we can talk about. So we can do some actual examples. So let's look at something called supplementary angles. So I always have a hard time spelling it. Supplementary angles. So these are special angles. So supplementary angles, they add to 180. So the sum of the angles is 180. So these add to 180 degrees. That's what it means when angles are supplementary. So if someone says, hey, I've got two angles and they're supplementary angles, then you know they add to 180. And the angles themselves are called supplements, just some extra knowledge there. And then complementary angles. So complementary angles. Okay, so these add to 90 degrees. So add to 90 degrees. And the angles are called complements. Okay, so if you have supplementary angles, they add to 180. Complementary angles, they add to 90. All right, let's go ahead and just do our first example here in this video. And this is a pretty easy example, which makes it pretty fun. So here we go. Let's start with a picture. And from the picture, we'll figure out the problem. So say we have an angle here like this. So here's our angle. And draw our angles here. So we have, oh, that's a bad picture. Let's do something like this. And then I'm going to draw an angle here. Okay, small angle here. And we'll say this is 3x. So let me just write it like this. Let's say this is 3x degrees. That's this angle here. And then we'll have another angle here. I'll use a different color. Use red. And let's say this one is 6x degrees. Okay, so we have two angles. We have this one and we have this one. And the question is to find x. So find x. This should be pretty fun. Maybe we can do it together. So solution. So we have two angles here and it looks like this is a 90-degree angle. So what people do to indicate that this is 90 is they put a little rectangle like this. I'll go ahead and include that. So whenever you see this symbol, it means that this is 90 degrees. So that means that if we add these angles, we should get 90. So if you look at the angle 6x, and I'm going to drop the, well, I'll include it for good measure. It's a bad joke. Plus 3x, that's equal to 90 degrees. And if you remember, these are called complements. So these angles are complements because their sum is 90 degrees. So they're complementary angles. Now, whether or not you include the degree here in your work is up to you. Generally, sometimes I'm lazy and I'll omit it. So sometimes you'll see me write stuff like this. But always include it in your final answer, right? So it's really important to include it in your final answer. So how do you add these? Well, just like you would in regular algebra, 6x plus 3x is 9x. And I'm going to go ahead and drop the degree symbol for now. And this is equal to 90. And then since the x is being multiplied by 9, we can solve for x by dividing by 9, like this. We end up with x equals, and that's equal to 10. Okay, so we've got x, but we're not done, right? Well, that was the question, to find x. But let's go ahead and take it further. Let's go ahead and actually find the angles. The question didn't want that, it just wanted x. To find the angles, what you would do is you would take your x and plug it back in. So your first angle would be 6 times 10. which is 60 degrees. And your second angle would be 3 times 10, plugging it in here, which would be 30 degrees. So now you have two angles that add to 90, so you see that they actually are complements. And yeah, kind of a fun, simple problem. Let's do another one just for practice. And this next one will actually change the directions up a little bit, and we'll say find the angles. So find the angles. Find the angles. And this time the picture is going to look a little bit different, about something like this. And let's say maybe it looks like this. And this is 4x and this is 6x. And I'm omitting the degree notation. But let's just include it in the problem and then maybe omit it in our work. So this time we have some angles that seem to add to 180. So whenever it's a straight line like this, you can just assume that this outer angle here is 180 degrees. Okay, this is 180 degrees. So whenever you have two angles that add to 180, if you remember, they are called supplements. So these are supplementary angles. So if we add these, 6x plus 4x, that's equal to 10x. Or rather 180. Messing up here, 180, 180 degrees. And yes, and it is equal to 10x, and that's 180. And you can divide by 10, divide by 10. So we get x equals 18. Okay. And then what you can do to find the angles is just like before, right? If you recall before in the previous example, we took the value of x and plugged it back in. So we can do the same thing here. We can take the 18 and plug it in here to the x's. So it'll be 6 times 18. Let's see, 6 times 18. So I don't have a calculator within arm's reach, but we should be able to do it in our heads. 6 times 10 is 60, and then 6 times 8 is 48. 48 plus 60 is 108. And technically, if we just leave it like this, it's an incorrect answer because we're dealing with angles and they were given in degrees, so we use a degree symbol. So that would be the correct answer there. And then here, for the other one, we plug in 18 into the 4x. Right here, put an 18. So this is going to be, let's see, 4 times 10 is 40. 4 times 8 is 32. So 40 plus 32 is 72. And again, you could use a calculator. A calculator is typically used in a course like trigonometry. So if you don't have one, it helps to have one. And those are our angles. And again, because they add to 180, they are called supplements. And you can check your answer. You can check it by making sure that they add to 180. So if you do 108 plus 72, sure enough, you get 180 degrees, so it checks. You'll notice here in the computation, I omitted the little degree symbols. So again, something I have a habit of doing. Whether or not you should do that, it depends. Like if you're taking a class in college or high school, or for anything, it's better to include it. But in my opinion, it's a little bit acceptable, especially as long as the answers do have the degree symbol. If you're wondering why it's not assumed that it's there and why you have to write it, it's because later on in this series of videos, we're going to learn about something called radians, and that's another way to measure angle measures. So I hope this video has made even just a little bit of sense. If it has, then mission accomplished. Good luck and take care.